Today we are going to talk about finding limits algebraically. By the end of this video, you should be able to find limits algebraically without a calculator, and you should be able to evaluate a limit using the difference quotient. First, we want to use direct substitution to evaluate the following limits. We have the limit as x approaches -1 of x squared plus x minus 6. Your first attempt at finding a limit should always be direct substitution. So if I go ahead and plug in -1 for x, I get 1 minus 1 minus 6, which is -6. For the second example, we have the limit as x approaches -1 of x squared plus x minus 6 over x plus 3. Again, we can start by trying direct substitution. So here we would have 1 minus 1 minus 6 over -1 plus 3, or -6 over 2, which is -3. But let's look and see what happens in these situations. First, we have the limit as x approaches -3 of x squared plus x minus 6 over x plus 3. If we try direct substitution, we end up with 9 plus -3 minus 6, which is 0, over 0. We call this indeterminate. Whenever we have 0 divided by 0. In the last set of notes, we would have then gone to our calculator and used either the graph or the table to help figure out what the limit is. But we don't have to do that. We want to simplify this rational function, so we're going to start by factoring. So this is equivalent to the limit as x approaches -3. If I factor the numerator, I have x plus 3, x minus 2, over x plus 3. I can cancel the x plus 3's and just have the limit as x approaches -3 of x minus 2. Now, since I have simplified this rational function, I can do direct substitution. So if I plug in -3 for x, I get -3 minus 2, which is -5. Let's look at the next problem. I have the limit as x approaches 1 of x minus 1 over x cubed minus x squared plus x minus 1. You can go ahead and try direct substitution, but I'm just going to tell you we're going to get indeterminate form again, where we have 0 divided by 0. So we need to factor. The first thing I'm going to do is factor the denominator. Since we have 4 terms, you want to do factoring by grouping. So I'm just going to focus on the denominator and factor by grouping. So if I have this denominator and I want to factor by grouping, you want to factor out the GCF of the first 2 terms, which is x squared. Factor out the GCF of the second 2 terms, which is just 1. Then you are factoring the GCF out again. You are looking at the first term and the second term to see what they have in common. They both have an x minus 1. And when I take x minus 1 out, I'm left with x squared plus 1. So I have the limit as x approaches 1 of x minus 1 over x minus 1 times x squared plus 1. The x minus 1's cancel out, so I have the limit as x approaches 1 of 1 over x squared plus 1. Now I can do my substitution. If I plug 1 in for x, I end up with 1/2. You can verify this by looking at the graph or the table. Let's try one more. Here I have the limit as x approaches 0 of square root of x plus 1 minus 1 over x. If I try direct substitution first, I end up with an indeterminate form, 0 divided by 0. This is not something that I can factor, so another technique that we can use is to multiply by the conjugate. And I'm going to multiply by the conjugate of the numerator. So I'm going to multiply by square root of x plus 1 plus 1 instead of minus 1. This is the conjugate. So now, if I go ahead and multiply, I have the limit as x approaches 0, and here I need to double distribute or FOIL in the numerator. So I have square root of x plus 1 times square root of x plus 1, which is just So I have square root of x plus 1 times square root of x plus 1, which is just x plus 1. Then square root of x plus 1 times 1, so positive square root of x plus 1. Negative 1 times square root of x plus 1. And then negative 1 times positive 1. And I'm not going to distribute in the denominator. And you'll see why in a minute. If I combine my like terms in the numerator, my square roots cancel out, and so do my positive and negative 1. So I have the limit as x approaches 0 of x over x times square root of x plus 1 plus 1. I can cancel out the x's, and I'm left with the limit as x approaches 0 of 1 over square root of x plus 1 plus 1. Now I can go ahead and do my direct substitution. If I plug in 0 for x, I end up with 1/2. Now, there are two special limits that you need to memorize. The limit as x approaches 0, sine of x over x is equal to 1. When you plug in 0 by direct substitution, you end up with 0 divided by 0. But there's not really an algebraic way to simplify things. You have to use a different technique called the squeeze theorem, which we're not going to get into. Similarly, the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. So you need to memorize these two special limits. Lastly, we have if f of x equals x squared minus 1, then find the limit as h approaches 0 of f of 3 plus h minus f of 3 divided by h. This is called the difference quotient. And it is an important thing in calculus. We won't get into the details here. We'll talk about that later. So, to start with, we need to figure out what f of 3 plus h is. So this means I'm taking f of x and plugging in 3 plus h for x. Now I need to do my algebra. I need to square this binomial. So I get 9 plus 3h plus 3h plus h squared minus 1. So if I combine all my like terms, I have h squared plus 6h plus 8. I also need to figure out what f of 3 is. And this means that I plug in 3 for x in f of x. This just gives me 8. So now I have the limit as h approaches 0 of f of 3 plus h, which was h squared plus 6h plus 8, minus f of 3, which is 8, over h. So I need to simplify and then evaluate this limit. If I combine my like terms in the numerator, I end up with h squared plus 6h over h. I'm going to factor the GCF in the numerator. So I have h times h plus 6 over h. The h's cancel, and I'm left with the limit as h approaches 0 of h plus 6. If I plug in 0 for h, I get that our limit is 6. We will use the difference quotient more in the future, but for now, you just need to know how to do the algebra to simplify things and evaluate the limit.